Good day, guys. So today we'll be looking at the hardware product lifecycle. I'll be going through lots of things. We're going to look at from idea generation to requirement to the architecture of your product to designing the product and having your first prototype, test and manufacturing. And I said there that building a hardware is a process, not a single step. It's a process, not a single step. That is why, as a hardware engineer, you need to think in systems, you need to think in processes. So it's not just about a single step of designing a schematic or a PCB layout and thinking that everything is done. We need to consider various things right from the start to the manufactured hardware products. So let's move on. So we have here idea and requirement. So when starting a hardware design, first of all, we first start with the idea or the concept. And here it talks about identify a real problem and the target user. Identify a real problem. So once you come up with an idea, you need to know what the problem is so that you can actually give the problem a good solution. Again, let's just take a home automation system, for example. And let's say you need to monitor the temperature of your room or of your house. So since you have gotten the problem, they need to give it a good solution. That means in your system, you know that you need to have various sensors like the temperature sensor or the humidity sensor to add up to it. Then you do your design and you get your perfect solution. And also you need to know the user, which user is going to use this product. Is it which application is this product going to fit in? Is it an industrial application? Is it an automotive application? Is it a consumer-based application? This will give us insight of better product designing. So once you've gotten the idea and the concept and the problem, and you've identified the problem, then the next thing is requirement. Okay, requirement. The next is to define the requirements. So yeah, it says requirements define what the product must do. You get. So now you need to start gathering the requirements. What must this product do? If I want to measure the temperature of the home of my room, you start gathering the things that are needed to do that. Your sensors, your microcontrollers, you're getting the requirements and putting all those things together. Yes. Then we'll have power, cost, size, performance, environment. These are still part of the requirements gathering. Yes. So what will be the total cost of the board? What size are we looking at? What is the performance level? What environment is it going to work in? These are part of ideas and requirements. Then the last one here, we have clear requirement guide, good design decision. This is very important. When you have a clear requirement, when you have um, a good requirement or we have clarity in what you want to design, it will help you to make good design decisions in terms of selecting components, either your microcontrollers, in terms of sensor selection, and also why this is important. Let's say we want to measure the temperature of our room. We need to know, or the temperature of an environment. Having good requirements help us know what to measure based on precision. You get. Do I want to get a temperature sensor of about 5% accuracy or 1% accuracy or blah 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 to give you good precision? Then next we have system architecture in hardware development cycle. So defines how the system is structured. This defines how the system is structured from the power section to the sensor section to the MCU to the connectivity. Most times, system architecture is telling you what power is being used in which section. Is the system battery powered? Is it taking power from the AC adapter? What protocols are being used? What connectivity options? Is it Wi-Fi? Is it using Wi-Fi? Is it using Bluetooth? Is it using just so many. You get it. System architecture helps you understand all that. So in all this part also, I wrote interfaces and power flow are also decided in the system architecture. Interfaces and power flow. Then at the last, I wrote good architecture simplifies PCB design later. So when you have a good system architecture, it helps you simplify your PCB design and it helps you simplify your entire hardware process. It helps you know the kind of component to select. It helps you know the communications that you're going to use. It helps you know the protocols you're going to use. And it just gives you clarity. It gives you a high level view of the technicalities that are embedded on your design. So next we have design and PCB development. So this year we start doing our schematic design, like what you have here on the screen. We start doing our component selection. Oh, we need to select the temperature sensor. We need to select the microcontroller, the MCU. We start doing our PCB layout. Then we have your power designs, interfaces, and protection circuits. So this is just talking about the design and development, your PCB design, your schematic design, generating your manufacturing files also. Then here I wrote PCB design belongs here, not earlier. Yeah. So it gives you perspective in all this you're doing. Then the next one, which might be the last, prototype and test. Prototype and test. Build prototype to validate the design. Sometimes also when you're designing when you're working on a hardware project, on a hardware product, it's always good to have prototype designs, because when you build your prototypes, you can be able to test some functionalities like power, like embedded protocols and other stuff, so that you know where trade-offs are, so that you can do a better design that can actually be deployed to the market. Then I said here, problems here are expected and useful. So you identify problems in your prototype design and you test and you do the second iteration or the third iteration to get a better product. Then lastly, yeah, I say manufacturing, and we just have a key takeaway. So prepare for scale, design for manufacturing. This DFM. DFM means design for manufacturing, design for test. Then your bomb generation, bill of material. Bill of material is just talking about all the components used in your design and all that. Then we'll have our production files. Then a working prototype is not a finished product. And get a working prototype is not a finished product. It's always good to separate prototype and the actual product, because we just design prototype in order for us to test and identify problems, further problems, so that we can actually design a better product that can be shipped to the market. Then we'll have here that good hardware follows the right process. Then knowing when to design matters a lot. So thank you guys. This is for this, the hardware design life cycle. Then from our next videos, we'll start our design majorly. We'll be talking about, we'll be looking into component selection and what is a PCB, and um, also understanding the KiCad software and actually downloading the KiCad software and using all that. So I want you guys to like, subscribe, and also share this. Thank you guys.